70 years ago, the nuclear bombs dropped over Hiroshima and Nagasaki exploded and to this day remain the only use of nuclear weapons for warfare. But with around 15,000 warheads remaining in the world, what happens if we have a nuclear war? The impact of a single nuclear bomb depends on many factors like the weather, weapon design, geographical layout of where the bomb hits, and if it explodes in the air or on the ground. Approximately 35% of the energy comes in the form of thermal radiation or heat. Since thermal radiation travels at approximately the speed of light, the flash of light and the heat come several seconds before the blast wave, and this causes flash blindness to anyone looking, a temporary blindness of a few minutes. With a 1 megaton bomb, which is 80 times larger than the Hiroshima bomb but much smaller than many modern nuclear weapons, those 21 kilometers away would experience flash blindness on a clear day and even up to 85 kilometers away on a clear night. Thermal radiation burns happen closer to the bomb, with first-degree burns occurring around 11 kilometers, second-degree burns at 10 kilometers, and third-degree burns destroying skin tissue at 8 kilometers. Third-degree burns that cover over 24% of the body will likely be fatal without quick medical care. These distances are variable depending on the weather and what clothing you're wearing. White clothing, for example, can reflect some of the energy, while darker clothes absorb it. At its center, the Hiroshima explosion was estimated to be 300,000 degrees Celsius, which is over 300 times hotter than the temperature bodies are cremated at. This intense heat reduces a body to its basic elements. The radiation from the blast also behaves like sunlight, so objects cast shadows where the radiation doesn't directly hit. But most of the energy released in a nuclear explosion is in the blast, which drives air away from the site of the explosion, creating a sudden change in air pressure that can crush objects or knock them down. If we use a 1 megaton bomb as an example again, within a 6-kilometer radius, there would be an estimated 180 tons of force on the wall of every 2-story building, with wind speeds of 255 kilometers an hour. Within a 1-kilometer radius, the peak pressure is 4 times greater, and wind speeds reach 756 kilometers an hour. The human body can endure this amount of pressure, however, the winds would create fatal collisions with nearby objects, so deaths would largely be from collapsed buildings. All this at 1 megaton. Compare that with the largest nuclear bomb ever detonated, the 50 megaton Tsar Bomba dropped on an isolated island in Russia, and you're looking at 3,333 Hiroshima bombs combined. If you happen to survive all this, now you have to worry about radiation. Now, not all radiation is harmful. We're exposed to different forms of radiation every day, like our phones, but ionizing radiation at the center of a nuclear bomb has enough energy to rip electrons from atoms. But the amount of radiation you encounter is greatly affected by whether you're outside or inside, in a wooden structure or a cement structure, and so on. Exposure to 600 REM radiation has a 90% chance of creating fatal illness, while a dose of 450 REM is estimated to create a fatal dose within half of those affected. But even those who recover still suffer long term. Molecular bonds and strands of DNA are broken, and while most repair, around a quarter don't, which can result in future genetic mutations and increased probability of cancer. Then there is the fallout. When a bomb is detonated on or near the surface of the Earth, the blast creates a crater, and the material that used to be deposited in the crater is carried up into the air as vaporized dirt particles, forming the familiar mushroom cloud. These particles become radioactive and eventually condense and come back down as fallout. Depending on wind conditions, radioactive fallout can travel for hundreds of miles. And though it can fall in the form of black rain, for the most part you can't detect fallout with your senses. Luckily, fallout radiation decays fairly quickly, and within 2 weeks, material will have declined to about 1% of its initial radiation level. But you would have to stay in a shelter until then. So what if a multi-bomb nuclear war broke out? A recent study imagined what 100 detonated warheads, the approximate size of a Hiroshima bomb, would look like if India and Pakistan went to war. These two nations have relatively small stockpiles of weapons compared to countries like the US, Russia, and China. However, this would still do huge damage. After the nuclear exchange, 5 megatons of black carbon would immediately enter the atmosphere, causing global temperatures to fall and receive 9% less rain annually. Though these changes sound small, they could be enough to trigger crop failures and famine. A separate study estimated 2 billion people would starve in the wake of a 100 A-bomb war. So what should you do? We created a video called How to Survive a Nuclear War that looks into strategies for safety in the event of a nuclear bomb near you, which you can click on here to check out. Don't forget to subscribe for more weekly science videos every Thursday, and click that bell to make sure you get notifications for our videos. We'll see you next week.